This is Unit 8, Day 2 notes. This is on page 16. Page 16. I'm going to do number 2 for you for an example. Hopefully to help you out. We're going to do it with a sum and a difference. So here we go. We have the angle 5 pi over 12. And you might say to yourself, wait a minute, on our unit circle, I don't remember anything in radians being out of 12. And you're right. It's really not. I mean, this is pi over 6. This is pi over 4. And pi over 3. The only great news is we can actually make these all out of 12. This would be the same thing as 2 pi out of 12. This here would be 3 pi out of 12, and this would be 4 pi out of 12. And sometimes we have to manipulate things a little bit even more so we can come over here. This is 2 pi over 3. Don't forget your pi over 2. Pi over 2, that would just be the same thing as 6 pi over 12. 2 pi over 3, that's going to be 8 pi over 12. 3 pi over 4 is going to be 3 pi over 4 is going to be 9 pi over 12. 5 pi over 6, that'd be 10 pi over 12. So with these, hopefully we can come up with some that will add up to 5 pi over 12 and some that will be subtraction. I think right now the easiest one to be, of course, would be subtraction, I believe, because if we took 8 minus 3, that gives us 5. So if I took the cosine of 8 pi over 12, which is the same thing as 2 pi over 3, minus 3 pi over 12, which is pi over 4, I would get cosine of 5 pi over 12. Does everybody see how I did that? 2 pi over 3 is 8 pi over 12. Pi over 4 is 3 pi over 12. So if you subtract those two, you get 5 pi over 12, which is the angle that you wanted. Right there, 5 pi over 12. And so we can rewrite it this way. Now, remember, we just talked about cosines. The difference cosines is you take the cosine of 2 pi over 3 times the cosine of pi over 4. Because this is a minus sign, we're going to do the opposite. So that's going to be plus sine of 2 pi over 3 and the sine of pi over 4. Okay? Well, so the cosine of 2 pi over 3, here's 2 pi over 3. The cosine there is going to be a negative 1/2. Cosine of pi over 4 is square root of 2 over 2. Plus sine of 2 pi over 3 is positive square root of 3 over 2 times the sine of pi over 4, which is square root of 2 over 2. That gives us negative square root of 2 over 4 plus the square root of 6 over 4. They have common denominators already, so you could just write it as negative square root of 2 plus square root of 6 all over 4. Or commutative property states you could say the square root of 6 positive minus the square root of 2 because it's negative all over 4. Either of those would work. Let's come up with a sum one that would work. So if I'm finding two that add up to give me 5, well, I think it's 2 and 3. 2 pi and 3 pi. So 2 pi over 12 plus 3 pi over 12 definitely equals 5 pi over 12. So we could say that the cosine of 5 pi over 12 is the same thing as cosine of 2 pi over 12, which is pi over 6, plus cosine of 3 pi over 12, which is pi over 4. Okay, so based on my cosine identity, I would get the cosine of pi over 6 times the cosine of pi over 4. Since it's cosine and this addition is going to be subtraction here, sine of pi over 6 times the sine of pi over 4. Cosine of pi over 6, cosine is the x value. So the x value here at this point is square root of 3 over 2. The cosine of pi over 4, square root of 2 over 2, minus the sine of pi over 6, that's 1/2, times the sine of pi over 4, that's square root of 2 over 2. That's going to give us the square root of 6 over 4 minus square root of 2 over 4, Or in other words, the square root of 6 minus the square root of 2 all over 4. And you can't combine those two because they're not like terms. And you're done. In this case, they end up being the same. They won't always happen. Well, no, in this case, actually, they would happen to be exactly the same because we're just trying to find the cosine of 5 pi over 12. All your answers, actually, you'll find out, will look a lot similar to this, just little differences here and there. They won't all be the same. But if you find it this way when you do a sum, or if you do a difference, they are the same. So, folks, we're done. I hope that helps. Have a great day. See you later.